Starting with circle ABC, let's draw line AB, which is the diameter of the circle, and we can label D as the center of the circle. There are several things we want to prove in this proposition. The first is that if we draw a line that is perpendicular to AB at A, this line will not be inside the circle. We will prove this part by contradiction and assume that it does. Say AC is perpendicular to AB and it falls inside the circle. Let's connect DC. DC and DA are radii of the same circle, so they are equal, and DCA is therefore an isosceles triangle, and therefore angle DCA is equal to angle DAC. Angle DAC is a right angle, so angle DCA is also a right angle. So we have a triangle where two of its angles are right angles, which is not possible, so the line perpendicular to AB will not fall inside the circle. Euclid notes that neither does it fall on the circumference of the circle, which would be proved in the same way. Now we know that this particular line will fall outside the circle. Let's draw it as AE. The next part we want to prove is that there is no line that we can draw between AE and the circle. We will again use a proof by contradiction and say that we can draw AF. Now let's draw DG such that DG is perpendicular to AF. It will cut the circle at H. So angle DAE is a right angle, so angle DAG is less than a right angle. Angle DGA is a right angle. Therefore, with triangle DGA, we know that side DA will be longer than side DG. But DH and DA are radii of the same circle, so DH is equal to DA. So DH is also longer than DG, which is absurd. So we have found another contradiction, and no line, such as AF, is able to be drawn between AE, which is perpendicular to AB, and the circle. The third thing we want to prove has to do with the angle between BA and circumference AHC, as well as the angle between AE and circumference AHC. Now we can't talk about these angles normally, in terms of right angles and such, because we haven't defined right angles in terms of curved lines, only straight lines. But we can say that the angle between BA and circumference AHC is greater than any acute angle. This is apparent from what we've already proven, because with line AC, we can make any acute angle BAC, which is always less than angle BAE, a right angle, inside of angle BA circumference AHC. So, angle BA circumference AHC is always going to be greater than angle BAC, which is any acute angle. Returning to the angle between AE and circumference AHC, we have demonstrated that there is no line AF in between these two things. So, clearly, there is no acute angle that will fit in between these two things either. So, this particular angle must be less than any acute angle. A porism that Euclid draws from this is that this line AE, perpendicular to AB, touches or is tangent to the circle.